Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syarul Hisham bin Mat Yusof. My matric number is AA200055. So my group members is Muhammad Izzat Iqmal bin Muhammad Zaini, AA200515. Muhammad Amzal bin Arifin 200, AA200664, and Muhammad Aiman bin Rahman, AA200732. So we are from group 5 and we will present about our project assignment. So that's all from me. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Iqmal bin Muhammad Zaini. My matrix number is AA200515. Okay, now I will present about introduction in my group. So I will brief for you 4 things. That is flip-flops, counter, finish state machine, and register. Okay, first let's go to the flip-flop. Okay, as we can see, a flip-flop is a digital logic element used for storing binary data. An element that capable of storing data is often called a memory latch. Flip-flops are basic building blocks in the memory of electronic devices. Each flip-flops can store 1 bit of data. The 2 kinds of memory encountered in digital electronics are static and dynamic memories. The flip-flop is the basic form of static memory and is also the building block for sequential logic circuits. A primary characteristic of sequential logic circuit is the ability to store the state of input memory. The term flip-flops is used as they can switch between the states under the influence of a control signal. They can flip to one state and flop back to other state. Flip-flops are formed from pairs of logic gates which are in turn made of transistors, where the gates outputs are fed into one of the inputs of the other gate in the pair. This results in a regenerative circuit having 2 stable output states. The 2 stable states are high and low. Frequently, additional gates operated asynchronously. Most are operated under clock control in a synchronous system. Some of the most common flip-flops are SR flip-flop, set reset, D flip-flop, data delay, JK flip-flop, and T flip-flop. There are various types of flip-flop used in digital electronic circuits, and the application of flip-flop such as counter, frequency dividers, shift register, storage register, bounce elimination switch, data storage, data transfer, and latch. Okay, second is counter. Counter is a circuit designed with a digital logic to obtain information, the number, and used for counting first. Counter can store and sometimes display the number of times a particular event or process has occurred, often related to a clock. The most sequential digital logic circuit with an input line called the clock and multiple output lines. Counter have 2 versions called as asynchronous counter and synchronous counter. Okay, for the asynchronous counter, it also referred as ripple counter. The simple in design among the other counter because has the least quantity of hardware required for this counter. For the other counter that called synchronous counter, each flip-flop in the circuit gets triggered with the same clock at the same time by connecting each flip-flop line with a single clock. The operation that occurs in such type is synchronized with flip-flop present. The difference about asynchronous counter and synchronous counter is like a table below. For the left is asynchronous counter and right is synchronous counter. Okay, there are various types of application in counter such as analog to digital converters, frequency converters, frequency counter, timers, digital triangular, wave generator, and digital clock. Okay, this is the finite state machine. It's also known as finite state activation. FSM is a calculation model that can be executed with the help of hardware or software. This is to create sequential logic as well as FSM used to solve the problem in fields like mathematics, games, and artificial intelligence because it has systems that can cause changes in state that can be significant. The finite state machines are significant for understanding decision making logic as well as control register system. In FSM, The output is a present state for the input function. It means that the selection of the state is mainly depends on the past input value for deciding the output. This proves that FSM is very understanding the sequential logical rule. Okay, let's go to example. Example for the FSM application is a vending machine, a subway entrance turnstile, and a heating pattern. Okay, last is a register. Register is a device which is used to store multiple bits of data and needed multiple of flip-flops. It is a group of multi flip-flops that were connected in series to store such information. The information stored within this register can be transferred with the help of shift registers. The bits stored in be made to move within the register and in or out by applying clock pulse. Bit shift register can be formed by connecting flip-flops where each flip-flop stores a single bit data. The registers which will shift the bits to left called shift left register, while register which will shift the bits to right called shift right register. There are various types of applications that can be found with registers, such as storing data in digital form, hold data and address, and digital memory. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Hamzah bin Arifin, and my matrix number is AA200664. Okay, today I'm going to show you the state diagram. The first is 011, 001, 111, 010, 100, 100, 000, 101. Okay, next state table. Okay, present state QC 0 0 0 0 1 1 1 1, QC 1 1 1 0 1 0 0 0, QB 0 1 1 0 1 0 0 1. Okay, next state table QA 1 1 0 1 0 1 0 0, QB 0 0 1 1 0 0 1 1, QA 0 1 0 1 0 1 0 1. Okay, for the excitation state, present state QC 0 0 0 0 1 1 1 1, QB 0 0 1 1 0 0 1 1, QA 0 1 0 1 0 1 0 1. Okay, next state same. Okay, FFC JC, for JC 1 1 1 0 X X X X, KC X X X X 0 1 1 1. Okay, for FFB JB 0 1 XX 1 0 XX, and for KB XX 0 1 XX 1 0. Okay, FFA for JA 1 X 0 X 0 X 0 X, for KA X 0 X 0 X 0 X 1. Okay, this is the K map. FFC J input, JC equal to QA plus QB, and then K input KC equal to QA plus QB. Okay, for FFB J input JB equal to KC plus QA, and for K input KB equal to QC plus QA. Okay, for FFA J input JA equal to QC times QB, and K input KA equals to KC times QB. This is the circuit connection. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Rahman. My number matrix is AA2007 and 32. Okay, today I will present to you about our group assignment task, which is digit electronic. Okay, for this is the TINKERCAD, and this circuit is for question number 1, and this circuit also based on the state diagram that my another teammate produced. So we can look here. This is how how looks the circuit. Okay, for the result we can look we can see the result after we start the simulation. Okay, I will start the simulation. Okay, so this is the result. The output here shown the LED light. Okay, turn on. Okay, so this is how shown the power supply. And this is the function generator. We have switch. Okay, that's all from me. Thank you. Okay, assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Rahman, and my number metric is AA2007 and 32. And this is the simulation or the result of the for the question number 2 from my group, and this is for the LOGISIM circuit. Okay. Okay, this is how node we have node about 5 node here. This is the flip-flop here, and input and also the output. So yeah, this is the circuit that we do. Okay, that's all from me. Thank you.